In this video, I'll be talking about the permittivity of the medium. First, before talking about the permittivity, let's go back to the Coulomb force. What is the Coulomb force? Let's say you have two charges, Q1 and Q2. It could be either positive charges, negative charges, it doesn't matter. And the spacing between the two charges is R. So R is the separation between the two charges. So the force between the two charges, either attraction or repulsion, between the two charges is directly proportional to the product of the two charges. The more the charge is, the greater will be the force. Okay, so the force again is directly proportional to the product of the two charges. And the force between again these two charges is inversely proportional to the square of the distance, which is given here. That means if you increase the gap between the two charges, the force will decrease by inverse square law. So now let's say if the distance between the two charges is 1 centimeter, and if I make the separation 2 centimeter, then the force will decrease by 4 times. Okay, it will go down by 4 times because it is directly proportional to the square. So now what we have to do, the force between these two charges is now given by this equation here, where we have introduced a constant K. This constant is also 1 over 4 pi epsilon naught. Okay, and the value of K is given by this number, 9 times 10 to the 9 Newton meter square per Coulomb square. And this is a constant for free space, or for the air, or for the vacuum. And in this equation, this epsilon naught is again another constant that is called the permittivity of free space. So this force here is only for air. Here, let me write down here. This force is for the air. Air. Okay. So what happens now if I place these two charges in some other medium? Let's say, for example, in water, in ammonia, in calcium, in wood, or in any acetone, in any other medium. So for example, let's say you have these two charges and place them in water. Now the medium has changed. If the medium has changed, the force will change again. What will the force increase or force decrease? Now how much the force changes? So the force between these two charges, okay, these two charges is given by this equation here. Now here, instead of epsilon naught, I have written down epsilon. This let me write down here. This is called epsilon. And this epsilon is again a product of the two terms, epsilon naught times epsilon r. Okay, so this epsilon is epsilon times epsilon r. And we already know what is epsilon naught. The epsilon naught is the permittivity of the free space. And epsilon r is called the relative permittivity of the medium. And this epsilon is the permittivity of the medium. Okay, and epsilon r is the permittivity of the relative permittivity. And remember, this one does not have any units. It is just a number. This is just a number. Okay, now if just look at these two equations, equation number 4 and equation number 2. If you look at these two equations, and if I divide equation 4 by equation 2, what we get is a very simple equation. F medium is given by F air divided by epsilon r. Now this tells you something much more significant. And what is that? What does this equation tell you? If the force of attraction between the two charges in air is 100, let's say Newton, and then if you put into the water or into a medium, it will go down by this factor epsilon r. Okay, so the force, if you put the two charges in any medium, and if you compare to the force with respect to the air, it will always go down, because the lowest value of epsilon r is 1, which is for the air or for the vacuum. Okay, here I have listed some of the values: water, acetone, graphite. So for the water, the permittivity is 80. What does that mean? That means if you place the two charges into the water, then the force of attraction or repulsion will go down by 80 times. Or the force of attraction or repulsion will be 80 times smaller than the force of attraction or repulsion in the air. So the force, now let's say for the silicon, it is 11. That means if you have two charges in air, and again if you put those two charges into the silicon, then the force will be 11 times smaller. That's the significance of the permittivity or the relative permittivity, or in other words, this K value. So this one, the relative permittivity is the material property. It does not change with the charges. It does not have any units. It's just the material property. All right. Now let's now also talk about the how does it change the electric field. We know that due to a point charge, this is the electric field. Okay, 1 over 4 pi epsilon naught q over r squared. And now in a medium, the medium, we add another term, epsilon r. This epsilon r is a relative permittivity, or we also call the dielectric constant, is the same thing. Or also called dielectric constant. Okay. So again, if you just compare these two equations, divide, what you get is the electric field in the medium is electric field in the air divided by the relative permittivity or the dielectric constant. That means the electric field decreases if you place them into a medium compared with the air. Okay, now let's talk about the capacitor. So for the capacitor, the capacitance is given by this equation, and this is for a parallel plate capacitor. Okay, where A is the area of each plate, D is the separation between the two plates. Now if I introduce some medium in between, let's say in between some medium, some sort of medium in between, it could be water, it could be wood, it could be paper, it could be plastic, any sort of medium in between. Okay, then due to this medium, the permittivity or the capacitance will be given by this equation again, epsilon naught. Then I'm just introducing another term here, epsilon r. That is again the permittivity or relative permittivity of the medium, or the dielectric constant of the medium. What you see now, the capacitance in the medium is now C air times the the constant or the relative permittivity. So which means it is the product. That means if we place a medium in between, then the capacitance increases. If we place them, the two plates, into the water, the capacitance will increase by the 80 times, and the reason is the relative permittivity is 80 for the water. If you place the two plates into the silicon, it will increase by 11 times. So, and that's the reason if you open any capacitor, there's some medium in between, and the reason is the capacitance increases if you place them into a medium. So hopefully you understand what is the permittivity, okay, and what is the application, where you use it. So depending upon, like, if you place them in the force between the two charges decreases, the electric field decreases, but the capacitance increases if you place them into a medium. So the epsilon value, the or dielectric constant, is just the material property, all right, which determines what will be the force between the charges, which also determines what should be the electric field in the medium, which determines what should be the capacitance value. So that's it. If you have any questions, write down